All right, so I would like to thank the organizers for giving us opportunity to talk about our recent result. So Kumran gave a really nice summary of what has been going on for last few years. And today I'll talk very specific way of the things that we have done. And here are the list of collaborators, especially people in Seoul National University have contributed significantly. So outline of my talk is I'll talk more specifically 62,0 theories and 61,0 superconformal field theories. Then I'll talk briefly about 5D reduction of these 6D theories, and then I'll talk about T-dualities of little string theories. So 6D superconformal field theories, we had a nice summary of it. So we know, let's look at the A type of theory which can arise from theory on M5 branes. And for example, on single M5 branes, there's tensor branch with a two-form tensor field whose field strength is self-dual. And then one can have M2 brane ending on M5 branes, then in which case it plays a source and it will become self-dual string. And in the conformal limit, where M2, M5 branes are on top of each other, it will become tensionless. Now it's a non-Lagrangian theory, degrees of freedom increase to the order n cube. Now if we are in tensor branch, you can look at what kind of PPS configurations you have. You have order n, on each M5 branch there is a matrix tensor multiplet, which is half PPS. Then you can have a straight M2 brane connecting two M5 branes, which is again half PPS. And then you can have a quarter VPS self-dual string junction, which is, and so on. Now, if you compactify the theory to 5D, then you get a 5D super Yang-Mills theory with coupling constant proportional to compactification radius, so that instantons play a role of Kaluza-Klein modes. Especially, this leads to various constraints on instanton dynamics. For example, one has to have a threshold bound state of multiple instanton to represent momentum k along the compactive directions. For example, if you look at 5D Yang-Mills couplings, then you can see it has origin in 6D also. As I said, 5D Yang-Mills Karatang element comes from tensor multiplet. And W boson comes from the self-dual string wrapping the connecting two M5 branes and wrapping compactified circle. Now, interaction between W bosons and photons can arise from two elements, which has rather two different origins in 6D. For example, if you look at the structure constant in Lie groups, then you have a root and Karatang. It can be regarded as a self-dual string interacting with the tensor multiplet. On the other hand, if you look at the root, then whose sum is equal to 0. In this case, one can see it originates from quarter VPS junction, which you can wrap on a circle. Now, these quarter VPS junctions give us an idea about generalization of a Kapustin-Witten equation, which was done about 10 years ago. Kapustin-Witten equation is 1/16 BPS equation for monopole string junctions in 4D Euclidean space, where one locks the SO4 spatial rotation with SO4 SO6 R symmetries, and this is the 7 equations one can have. Now, if one think about this one in 5D context, then one can have an additional 1/16 PPS equation, which is a dionic one. So one can have a dionic equation plus Gauss's law. So one can naturally imagine the 6D generalization of that, where one locks SO5 spatial rotation with SO5 over R symmetry of the 6D 2,0 theory, in which case one has 11 equations. So in this case, of course, we cannot write quantum equations because we don't have Lagrangian. Rather, one can write down just abelian tail of it, and that can be regarded as a 6D 2,0 equation for self-dual string webs, which fills the space. And this will be, again, 1/16 BPS. One can think about index function, which is counting chiral PPS operators in the theory. So one has to think about define the theory on as 5 cross R, then calculate the index. So here's the For example, one can choose a supercharge, then define the index, which can be expressed in terms of path integral, which we heard from Kumran, so which can be regarded as a contribution from 3 fixed points. But unfortunately, we don't have Lagrangian for theory on S5 cross S1. So one wants to do some field theoretic calculation, or one can insert each elliptic genus contribution and then integrate over tensor multiplet, which is one way of doing it. So one way of doing calculation from field theoretic perspective is, instead of writing down theory on S1 cross S5, one can write a theory on S1 cross S5 by ZK. So, for example, if you look at the metric on S5, it's made of CP2 with a circle fibration over CP2. And one can mold out this circle by ZK with a certain twist which preserves supersymmetry. And then one can write down in very large K limit where a circle is very small, then one goes to the limit where we have time circle with CP2 space, in which case one can write a Lagrangian. And here is a Lagrangian. This is theory on S1 cross CP2, and one can choose twisting such that one can preserve A supersymmetries with parameter being fixed, and in which case one has a Yang-Mills term, and we have a 3D Chern-Simons term wedge product with scalar 2 form on CP2, and all the coefficients are locked to each other, so there is no additional degrees of freedom, and the overall coefficient is quantized as K over 4 pi square. And so this one is 16 supersymmetries, and one expects when K equal to 1, 2, 3, it has the enhanced supersymmetry like 10, 16, and 32. So for example, in K equal to 1 case, especially with a specific choice of a chemical potential, so we can get the exact partition function. And here is the result for SEN, and this counts basically quarter BPS, half BPS object, which has been also obtained by sort of different approaches. Now, in ground state of K equal to 1 case is given in terms of non-abelian flux being proportional to K-log 2 form, and this flux is diagonalized with, and this is given in terms of Weil vector, such that this one has basically negative instanton numbers from which one builds up the excited state by reducing the flux and adding the instantons. And the vacuum energy of this configuration has this quantity which is very similar to one appears in anomaly calculations. So one can calculate the index functions for SU2, SU3 case, and one can get all the, here's the momentum Q along the KK direction, so Q, Q square, and so on. And Q to the cube term, we can obtain this phi, and this contribution matches ADS-CFT calculation. So it tells that this field theoretic approach, it tells us right index. So now let's think about 6D 1,0 theories, about which we have done some works recently. So as we heard from Kumra, 1,0 superconformal field theory is made of 3 pieces: vector multiplet, hypermultiplet, and tensor multiplet, and they are coupled to each other, and such a way that gauge anomaly has to cancel. And the gauge anomaly is made of 2 pieces, and this part has to be canceled among the vectors and hypers, and then the last part can be canceled by coupling the tensor multiplet to vector multiplet and by Green-Schwarz mechanism. And there are many examples, and even there is classification. And here we'll just focus on 1 or 2 examples related to E8 M5 brain probing the E8 world. So we can think about it, then one can add additional AN minus type of singularity. So, and also we can T-dual it, and structure can represent in terms of O8 and 88 brains with NS5 brains, and this AN type singularity can be converted to ND6 brains. So here is the brain configurations. So for example, if you think about rank 1 case, so we have 1 NS5 brains or M5 brains probing the E8 worlds, then one can introduce K M5 brains, which can be T-dualized, and also so that we have a physics on K D2 brains, and here is the Kuiper diagram. with which one can calculate the elliptic genus of the theory. However, if one has multiple NS5 branes or multiple M5 branes, then this theory doesn't give you the right index, in the sense that if you look at transverse direction to NS5 brane, there's only three directions instead of 4 directions, so then one cannot turn on the one chemical potential. One can generalize this to multiple T6 branes, but only even number of T6 branes can end here, and so here is the theory on K T2 branes, and one can calculate the elliptic genus on fundamental string, or this self-real string. Now, instead, one can approach the same problem somewhat differently by introducing half NS5 branes on OA plus OA branes. Now, in this case, one can have odd number of T6 brane can end on it, and the theory on this 6D theory can be written in tensor branch as SUN 6D theory coupled to tensor through Green-Schwarz mechanism with number of hypermultiplets. And also from this half NS5 brane, one has one anti-symmetric hypermultiplet. Now, one can write a theory on T2 branes now with gauge grouping UK, and here is the quiver. Now, having a T6 brane adds to this additional component, especially if one think about single T6 branes. Then having a single T6 brane in IR limit is like not having one, so one answer is the same as one without T6 branes. So one can get again elliptic genus of the EA string using this formalism. Now one can define the index function, which is well-trodden, by turning on various chemical potentials and calculate it. Then here is the UN case, UK case. So here is the elliptic genus for single strings and 2 strings and more for arbitrary number of T6 branes. And then one can compare with the previous calculations and also look at check the global symmetry. Now, if we have single T6 brane, then as I said, it disappears in strong coupling limit. So SU1 theory is a 9 flavor, has to enhance the EA global symmetry. And indeed, the elliptic genus calculation shows us that this flavor symmetry, SU9, U9 enhances the EA. Now, SU2 case, because of, again, KG group is U2, SU2, now we had a flavor symmetry U10, but we know secretly that it has to be related to SP2 case, SP1 case, so flavor symmetry has to be SO20. And indeed, one can show that from index calculation that flavor symmetry is SO20. Now, SU3 case, we have 11 flavor plus 1 anti-symmetric hyper. Now, 1 anti-symmetric hyper is equivalent to fundamental, so there should be SU12 symmetries, and indeed one can again show that they are merging together into U12. So here is, for example, SP1 case. You expand the contributions, and both cases get the same elliptic genus with SO20 global symmetries. So SU3 case, one gets SU12. Now, let's think about the 5D reduction of the 6D 1,0 superconformal field series. Now, there's one famous example. If we start with 6D tensor theory with E8 global symmetry, and if we compactify on a circle which breaks the E8 symmetry to SO16, we get a SU2, 5D n equal 1 SU2 gauge symmetry with 8 fundamental symmetries, 8 fundamental hypermultiplets. Now, one can decouple this hypermultiplet by giving a mass term, reducing the flavor symmetries, then we get a 5D superconformal field series, where we get a SU2 with NF fundamental hypermultiplet. Then, as Seiberg argued that there is instantons, and it gives us additional U1 symmetry, and that these two symmetry merge into exceptional groups. So one can get a 5D superconformal field series with various global symmetries. Now, previous example tells us that generalization of this direction of SU2 to sp3, and also regarded as sp1, one can generalize to sp2, and so on. So if we start with 6D theory with sp1 with 10 flavor or SO20 symmetries, it turns out through the brane technology, T-duality, S-dualities, and from various starting points, one can get at least five equivalent 5D theories. So one can have sp3 with 10 fundamental hypers, or sp2 with 10 fundamental hypers, and so on. Or sp3 is 9 fundamental plus 1 antisymmetric hyper, and they have all different brane origins. Now, by decoupling various hypermultiplets, again, one can get a very rich variety of 5D superconformal field series. So, for example, here's a case where one studies sp3 with 10 flavor, then we are reducing it. As you give a mass term to the fundamental hypermultiplet, you get a Chern-Simons term induced. So here is the list of the theories with various Chern-Simons terms and various enhanced global symmetries. Now, it turns out that there's other type of generalization where one can do 60 SPN with A plus 2n fundamental case. Again, one can have 5D SUN type gauge group or 5D SPN type of gauge group, and they are all equivalent. Specifically, when SUN gauge group is with certain Chern-Simons levels, then it's equivalent to SPN. And that has been shown for specific case with various calculations. And here's the other examples. So, to the last, let me talk about T-duality between two little string series, 2,0 and 1,1 little string series. So, for example, if you look at the type 2A and type 2B little string series, they arise from the NS5 brane with various fundamental strings having a threshold bound state of NS5 branes. One can study their moduli space. You can look at the 2,0 case, which Kumlo talked about, in which case one of the interesting things is that because this is physics on NS5 branes, it means there should be there should be one M circle transposed to M5 branes. And then if a single M2 brane is wrapping this circle, then it's fundamental string. But if we have multiple M5 branes, then we have M2 brane connecting M2 brane connecting M5 branes, in which case fundamental string get fractionalized. So this is the 2,0 little string theory. Now 1,1 little string theory arises from the type 2B case. So low energy physics is given in terms of 1,1 super Yang-Mills theories. And instanton strings play a role of the fundamental string. And coupling constant is locked to the string tensions. In which case, in this case, again, one can define the index function which is counting the PPS object with which moves the speed of light along the compactified circles. And this PPS state can be either carried by perturbative contributions from the field, or you can get the stringy contributions. And then the T-duality means that if we have this reduced string partition function as with chemical potential for momentum and the chemical potential for winding, then if we expand it, then T-duality means that we are exchanging a momentum and winding number, which means we are exchanging the chemical potentials between 1,1 little string theory and 2,0 little string theories. And so here is perturbative contribution from various multiplets from 0,1, 1,0 point of view. And here is the, Kumla showed already these diagrams. Here is a theory on the 2,0 series. Here is the partition function given in terms of theta functions. For there's fractional V1 to Vn is basically chemical potential for fractional strings. And here is the partition function for various number of strings. And the 1,1 is instanton string, so instanton string dynamics is easier, simpler. And now in this case, there is no fractionalization of strings, rather there is a fractionalization of momentums, because one can turn on the SUN gauge holonomy along the circle. So here one can write down the dynamics, which again we saw it before, and one can get the exact partition function of the string in 1, case for k instant case, which is a formula one can obtain started by the class of and then evolved further, developed further, and this is the exact form. So with two results, one can test T-duality. There's a bit more of extra mode in type 2A case, but that one can take care of. And especially U1 case, it turns out to be interesting that one can get a string partition function. Then U1 case, one expects a string is free, and the multi-string partition function is given in terms of a Hackett transformation of a single string, which is telling us that it's free strings. But still, U1 case, it has many interesting features. For example, from brain pictures, this tells us that type 2 and type 2B U1 little string theory, basically through S-dualities, winding and the momentum exchanges, means that this function has to be symmetric on the exchange of winding chemical potential, and that's indeed one can see that it is symmetric. And also, by turning on the best term for hypermultiplets, one can see there is triality, which means the exchange of 3 terms. It should be symmetric, and there is triality of partition functions. Now, U2 case, again, as I said, there is fractionalization of the winding numbers and the fractionalization of momentum. And here is the chemical potential for V1 and V2. Then one can calculate the partition function for each series independently. Then you expand in terms of winding number and momentum fractionalization with the same chemical potential, but type 2B case, and if you calculate it, and it turns out to be identical. So here's the answer for that. So to conclude, we have calculated various things in superconformal field theories and little string theories. And what we did was basically trying to understand dynamics of self-dual string. But when you are in the symmetric phase where there is tension in the string, one could ask whether by just looking at the field theory on each of M5 branes or each of tensor branches and gauge theory plus self-dual string captures all the physics, or whether there is something more than that. And from our calculations, it seems that there's no additional physics but what we see on our eyes. And there are many other approaches which we heard about, and this will lead us to additional insight on the subject. And also, even though I haven't talked about it, there are additional partition functions one can think about these theories, and that's also a very interesting direction to think about. Thank you.
For questions and comments. Well, I have one.
Yep.
This funny relation between Casimir energy and anomaly polynomial.
Right.
Is it better understood now?
There is a different approach, which is calculating partition function on S5, and it arises from basically two-loop, and in which case two-loop diagram in Yang-Mills theory is basically arises from junction anti-junction composition. I said the 5D Yang-Mills theory originates from the 6D calculation, so in some sense they are sort of related to each other. And somehow I feel all this n-cubic degrees of freedom is related to junctions.
Any other question? No, let's thank you now.
Thank you.